Thank you for joining this session. I hope that both of us, you and I, will make the most out of it. So I am Samkelo Nene. I'm a lecturer from EIT slash ECST. So to quickly introduce you to these two institutes. About EIT, EIT is an international accredited education. So we're accredited in Australia. So we offer from certificates to diplomas, bachelors and masters. We also have a campus here at Midrand, Waterfall Office Park. And about ECST, we are sort of like a little sister of EIT. So we are accredited by EXA and also DHET. So basically we are South African accredited. We offer degrees in Bachelor of Engineering Technology, in Electrical Engineering, and in the upcoming year we'll be offering Mechanical Engineering as well. Our model is blended, and so it means that we have on campus and then also online. This is a disclaimer, by the way, that one is accredited in Australia and one in South Africa, because people tend to ask in terms of then which or how then can they affiliate with maybe with EXA if they go with EIT or ECST. However, there's more information in our website we can pass. That was a quick introduction about my institute. But today I'm here to talk about the importance of AI, or the use of AI and analytics when it comes to solar fleet maintenance. So these are our contents today. We will look at, we'll start with the basics of solar, then the challenges. We'll look at the importance when we speak of global energy transition, and thereafter we will look at the AI applications in predictive maintenance, and then we will also look at an example or sort of a company that is a startup on predictive analysis, and then we will then finish our presentation. So if you were to consider solar arrays, a typical smaller solar array is easy to manage and to maintain, which means that, or rather simply because it is or does not require specialized tools, it doesn't require technical expertise. Hence, users are able to then handle installation, basic monitoring, basic cleaning. Whereas if you were to compare with the large solar array, so imagine a city with thousands of solar panels. Obviously, they'll be in groups of arrays, in groups of PV plants. Then how can we know that each and every one of them is performing at its best? And this leads us to the scaling wall issue when it comes to solar operations. So in essence, scaling wall, what it does, it sort of hinders the rapid growth of solar operation. So it comes in different forms. So the first one being the truck roll waste. What does that mean? So let's say there is a problem with the plant in a remote area, and then we have to send an engineer to go and diagnose or whatever, or test the plant. And they travel all the way and only to find out that they came with the wrong parts or the wrong tool, or the problem could have been fixed remotely. And then they have to go back. It's costly, right? And then the other form is then inconsistent monitoring. So let's say we have our arrays, and then they are connected to our system operator where they look at it. However, if we rely only on humans, remember, human can look at so many dashboards. However, what happens is that small efficiency drops, they tend to get unnoticed and for weeks. And obviously then this builds up to thousands of lost revenues over time. So that's the second part when it comes to our solar scaling all of solar. So Again, this is our challenges. I'm sure we are all familiar, especially those who are technical. These are our sort of main challenges when it comes to solar fleet operation. Obviously, they range from environmental to electrical, where you see natural dust they need. If you were to then go to studies, you find that natural dust, what it does on the solar panel, it can reduce the efficiency of the system by up to 13%. And then so it's not shear. So what even tends to have even more greater impact on the module efficiency is solar shading. I'm not sure if anyone is aware of solar shading. Anyone aware of solar shading? You are aware. Thank you. So, for example, in solar shading, what will happen? For example, even with the dust as well, it can sort of block radiation from falling in some cells, which means that they won't be able to generate electricity, and in turn, these cells, they can then impede the flow of current, and hence we used bypass diodes to sort of create that flow of current to ensure that they continue to operate. Anyway, so dust and shading, and also when it comes to temperature, normally we say when it's sunny, hotty, when it's hot and sunny, it translates to more solar generation, right? That's what we think. However, if you were to consider temperature, or rather ambient temperature, if it's high, what it does, it reduces the panel efficiency by lowering the output voltage. And we'll get to that when we touch the last part of it. And going to the electrical side of it, we also have electrical fault. That's also remain challenge to solar fleet operation. So the main being inverter malfunctions and also wiring issues, which can cause sudden drops and also rapid drop in output. So the combination of all these factors, what it does, it degrades the performance of the overall system, and we have to find a way to fix that. So these are some of the important stats that we have to consider, especially when we talk about renewable energy. You know, the world has this agenda, or rather the countries have this agenda to manage climate change and global warming as well. So some of the stats from IEA, International Energy Efficiency, and also World Resource Institute. So from IEA, what we learn when it comes to the increase in the penetration or the share of the renewable in the energy mix, that you'll find that solar and PV are focused to account for 95% of renewable capacity expansion. So it means that we're expecting more solar panels to be added, more renewables to be added. It means more problem because we will have to have. It means we will have more power plants to take care and maintain. And then, if you then ask yourself, why is the reason? I've already told you the reason, or the main reason. That's been to manage climate change and global warming, though they are still valuable. However, application of AI in predictive maintenance, what it does, it leverages data analytics and also machine learning to improve the operation of the system. So what we'll do now, we will explore 3 of the applications of AI in predictive maintenance. We'll start with the first one, which is anomaly detection. So anomaly detection, so let's say there's a problem. We have a small fault in one of the panels or in one of the inverters. So this could cascade into a downtime, or it could cascade into a yield loss. So then what we'll need to do is then to put in place an algorithm using machine learning, machine learning and also anomaly detection algorithm to then predict or to sort of flag so there is the normal condition, What happens with anomaly detection is that it flags any abnormal that it sees on the system. So some of the KPIs I'm going to rush. I'm aware I'm behind time. Some of the KPIs we look for when we do anomaly detection is then what we want to reduce the maintenance cost. We also want to reduce the unplanned downtime, which will cost us the heat loss. And then going to the second one, which is automated visual inspection. So this can be used to complement anomaly detection. So here we use computer vision. So we use deep learning algorithms using convolution, network neurals applied to thermal and drone imagery. So we send out a drone to then go over the panels to take thermal pictures so that we can see if there's any temperature variation across the panels that could detect the declining of the efficiency. So this is automated visual inspection. And then going to the last one. So the last one is more about optimization and scheduling, because most solar fleet operators are struggling to optimize or schedule. What you'll find that when they're doing even reactive maintenance, they struggle with things like inefficient parts, logistics, and also things like perhaps to dispatch workforce. So these are our KPIs. When we're using this, we try to improve the technician utilization, to reduce the truck roll I spoke about at the beginning of the presentation, and then these become our data sources, what is on the ground. And then to implement AI predictive maintenance, these are the three components. So the first one, we have to then use machine learning to set performance benchmarks for panels, inverters. The second one, we then use thermal imaging with AI to then go and detect or take these thermal images, and then we use the Internet of Things centers for real monitoring to capture critical performance and also environmental data. So these are the main components when it comes to this. And then this is how we implement it. Whenever you implement AI predictive maintenance to a solar system, you then have to first identify critical assets. So you have to examine your hardware, and you also have to examine your data infrastructure. And secondly, you have to choose the technologies that you're gonna use. They have to be compatible with your system, and also they have to be real-time monitoring, because we wanna predict real-time. And also, in order for them to be predictable, they have to have open standard protocols. And then the last time, then we integrate. Obviously, when we integrate, we do this in a phased way. We start with the critical component, but before that, what we do a compatibility assessment. And then this is one of the solar software developers, so one of the companies, Smart Helio, who are leading in terms of AI predictive analysis. So this is sort of like their homepage. So this is one of their platforms, which is the diagnostic platform. What it does, it collects data from the monitoring portal, and then it provides real-time diagnostic and also provide real-time solution. And then this is their smart center, which is not the same as your typical data logger. Your data logger tends to send a lot of data to the cloud. However, this one, its data transfer is reduced by 80%, sending relevant data, which is good for data quality when diagnosing or analyzing. So this is their predictive and analytics tools. So they were done for a case study of one of the plants that they are monitoring in New Delhi, in India. By the way, they are based in Swiss. They have sort of plants which is part of their pilot project that they monitor using AI and analytics. So the first one is the data sanitation tool, where we see the data of the plant pre-sanitation and then after, and then post-sanitation. So they've used algorithms to clean the data. Initially, there was 2.42% missing data. This could have been due to a drop in system, and after it was cleaned, it was dropped to 0.03, which is good for data analysis. And then the second part is the cleaning scheduler. So you'll see that these are all inverters here, and each inverter will connect a set of strings. And you see these yellow blocks, which are prompts as to when then these sets of strings should be cleaned. And then obviously if you don't, it also shows you this part here, whereas it shows the predicted losses should you not then follow those prompts, how much you lose. So you can also download that sort of like calendar to share with your workforce so that they can arrange their routine. The third one is the module analysis, which analyzes the degradation of solar panel. So initially it shows the overall degradation, which is not bad. And then here it shows the degradation per strings of panels, so connected to these particular sensors. So it uses the concept of temperature coefficient of voltage. So I was going to explain it, but it's a long process, basically using the temperature coefficient of voltage, analyzing the change or studying the change in open circuit voltage over time, per degree Celsius, and then you compare that with the manufacturer's initial specification. If there's any changes, then you can detect. And then the last one here is more about forecasting. So our global horizontal irradiance forecast. So this one here, it gives different scenarios. Obviously, the solar energy availability is forecasted in relation to the climate change from aggressive mitigation and also to high emissions. So in essence, what they are looking here is that how solar will be impacted by the change in the atmosphere. And then moving on. So, however, this remains our challenges. You find that we have a lot of academic papers on AI-based predictive maintenance, but there are few companies who are using these technologies. You find that most of them are startup companies, they are pilots. You find that most utilities and regulators, they are a bit unsure because there isn't documentation or regulation whatsoever. And also the issue of commercial sensitivity. I think that you find so many studies on this, however, there isn't no full technical report, which then leads us to credibility. You find that most stakeholders who want to scale up investment, they want to see full, detailed, peer-reviewed evidence in order for them to scale investments. So the path forward is then to expand this project into utility scale, and the drivers of this will be then the continuing global renewable share rising, and also the economic pressure of O&M cost. And also in terms of our grid stability needs, we know that our PV plants are not reliable, they're inherently unreliable. However, we have to optimize them as much as we can. And also as we are decarbonizing, some countries are doing so. So that's all for today. Thank you for your time. I'll quickly leave. This is our EIT photo challenge. We have our prices. You can visit us at C10 near Solis. And then the last slide, you can have our certificates of attendance. So thank you for attending. Sorry for being long-winded. I tend to be like this in my classes as well. Thank you.